Good afternoon. This is a tutorial about titrations. Titration is the process of determining the concentration of a substance in a solution through a chemical reaction. In this case, we're going to have two different substances, an acid and a base, because we're going to use an acid-base titration as an example. So the chemical reaction that takes place is going to be a neutralization. In the burette, we will place the acid in this case, and that is the unknown solution. So we wanted to calculate the concentration of that. In the beaker, we have our Erlenmeyer flask that we can use too. We have a solution that we know exactly how much the concentration is and how much volume we are using exactly. So we are going to use some drops of an indicator, in this case phenolphthalein, for the acid-base titrations that we're going to perform, and the beaker is going to turn pink because of the phenolphthalein present. Now, the solution in the burette is going to be released slowly towards the beaker, and the beaker is going to begin turning colors when we are near to the ending point. The ending point is when all the ions in the beaker are neutralized by the ions in the acid. We know that the acids have protons in the in the formula, and the bases release hydroxides. So we're going to have basically the reaction that takes place here. Protons plus hydroxides gives me water. That is the neutralization reaction. This is the ionic equation for that neutralization reaction, meaning only the ions that are important, not the spectator ions. Regardless of the acid that we use or the base that we use, the neutralization reaction is going to be exactly the same. Some books, instead of using protons like only one hydrogen with a positive charge, they represent the protons as H3O. Protons do not exist by themselves, but surrounded by molecules of water, and that is the way of representing that. But either way, the reactions are exactly the same. Now, in the beaker, the indicator is going to be try to change colors, so we need to shake the beaker all the time, and when the end point or the ending point is reached, we're going to stop the releasing the liquid in the burette, and we're going to see that the pink color for the beaker disappeared. In this particular example, I put a measurement of the burette. You have to be very careful that the measurement of the burette is read correctly. In this case, it's not going to be 23, but it's going to be 17 milliliters of acid used. Be careful when you make the measurements. You have to estimate the last digit in the burette. In this case, it's going to be only 1 decimal. Now, for the calculations, there are 3 main steps to resolve the titration, and we're going to begin from bottom to top, because actually the number of moles that we actually know is the number of moles that appear in the, or they are present in the beaker. So the first thing that we need to calculate is the number of moles that are present in the known solution, in this case the base. And we know that we are going to do that through the formula of molarity. Molarity is equal to the number of moles divided by the volume in liters. We know the molarity, we know the volume, we can calculate the number of moles. So basically it's applying that formula. Now, after that step, we need to calculate which is the ratio between the ions that are present in the base and in the acid. For that, we need the formula of the acid and the formula of the base to see how many ions are present in each. In the example, I put sodium hydroxide and sulfuric acid, just for us to know that it's not always 1-to-1 ratio. In this case, for 2 hydroxides, we are going to need only one sulfuric acid, since the sulfuric acid has 2 protons and the sodium hydroxide has only 1 hydroxide ion. So 2 moles in the beaker will react with 1 mole in the burette. That is about the concentration, of course. The last step, once we know which is the ratio, we are going to use those number of moles to calculate the concentration in the solution of the burette using the amount of moles calculated in step 2. So let's see one example so we can understand better what I mean. In my example, I put that we use 17 centimeters cube of a solution containing sulfuric acid to titrate 25 centimeters cube of a solution 0.5 molar of sodium hydroxide. So we know that we have 25 centimeters cube of sodium hydroxide here, and we know that the molarity of the sodium hydroxide is 0.5 molar. So we can calculate the number of moles present here, and that's what we are going to do first. So the first step is calculating the number of moles present in the known solution. The volume is 25 milliliters. That always we use liters. Be careful with that. And the molarity is 0.5 molar. So the number of moles is going to be 0.0125 moles. Do not round until the last step, because if we round here, we are going to carry the error further on. So after that, we need to calculate the mole ratio. We saw that 2 moles in the beaker will react with 1 mole in the burette, since the formula that takes place in the beaker, or the reaction that takes place in the beaker, is the one that you have in the screen. So if 2 moles of hydroxide reacts with 1 mole of acid, and we have only 0.0125 moles of sodium hydroxide, we can calculate the value of X for the acid. So if you make the calculations, remember that when we do the calculations, you need to take the X and you're going to cross this, and you're going to multiply the ones that are not in the same area. So it's 1 times 0.125 divided by 2 is going to give me the value of X. So we can calculate the value, and in this case it's 0.00625 moles of sulfuric acid. After that, we are going to use the formula that we have here. Molarity is the number of moles divided by the volume of the solution. Why? We have the volume and we calculated the number of moles. So basically what you have to do is applying the formula again. Be careful, pass the centimeters cube of the volume use of sulfuric acid to liters always, and then you have the molarity is equal to the number of moles divided by the volume. The number of moles is the number of moles that we can calculated in step 2, and the volume is going to be the liters, or the volume that we use for the sulfuric acid. If you have any questions, please let me know. Have a nice day.